Lesson 4.5 is going to be our last lesson in this chapter. There are two other lessons that we're skipping, and so if we have time, we'll circle back. But for right now, we're going to be looking at dilations. So basically, a dilation is also a type of transformation, but in this particular case, a dilation is when you either enlarge or reduce. So again, like if you've ever gone to the eye doctor and maybe your eyes have been dilated, things like that. So that's what a dilation is all about. Now, in a dilation, we have the center of dilation, so that's kind of the point where it's like occurring from. Now, the center of dilation is not really a super big thing. I kind of put it under one of the key points. I think this one is just more like good for you to know that the points line up in a straight line. Okay, so let me just say here, straight line to center of dilation. Now, in our particular class, we're just going to be observing them, like looking at them already. We don't have to do a lot of drawing of dilations. So this key point more comes into play when you actually have to draw them, all right? So again, it's just kind of more good for you to know. One thing that is also kind of an interesting key point is the angles. Now maybe look at R here, or if you can look at P. If you notice, the angle of R does not change when it becomes dilated. So the angle measures are preserved. And again, these are more just kind of good for you to know and just have a general idea about dilations, but the really key piece here is the scale factor. And so that's why I'm going to put it under 3, because I have a little bit more room to work, okay? So a scale factor. First of all, people in math, they love abbreviations. And so for whatever reason, they use the abbreviation K. And they usually do it as a lowercase k. I don't have a good explanation of why. That's just kind of often how you see it. So if you do it as a capital, it's no big deal, okay? So the scale factor is often represented as K. If K is over 1, then that means this is an enlargement. So it means it got bigger. If K is between 0 and 1, so like let's say it's 0.6, then that would be a reduction. Now, if you're wondering about negatives, they don't do any negatives in this chapter, kind of like with rotations, because negatives not only, let's say, would make it, like let's say this was, let me use a pencil here, like let's say this was negative 1.6. The 1.6 would make it bigger, but the negative would actually rotate it. So in this particular chapter, they just don't do any negatives at all. So you just don't have to worry about negatives, okay? Now, how do you find scale factor? You always do the image over the original. That's what you always do. So if we look up at this particular picture, it does not matter which side you pick, but notice the image is on top. So let's say I pick side PR. You can pick any one of the 3. So whatever side you pick, let's say you pick PR, you would measure it, and then you would also measure the corresponding side. So P prime, R prime. And then you just would probably grab your calculator and type them in, and then whatever that number comes out to be, that's the answer. Now, because of everything going on kind of with COVID and whatnot, if you notice, your problems are going to look like the row down here, 4, 5, and 6, where the measurements are already on the picture for you, so you don't actually have to worry about measuring them yourself. So I'll do number 4, and then you can kind of pause the video and try it. But out of these key points up here, this is really kind of the scale factor is the biggest thing that you're going to be asked to do. So if I'm looking at number 4, notice that the original is down here, okay? Now, in this particular case, do you notice that they did not give us the side length? So see how they don't give us one of these sides, but they're giving us the distance from the center, which that's okay. So The first piece I want is the distance to the original, because I want the original on top, the image. Or sorry, yeah. I want the I want the pre-image on top. Sorry, I have this mixed up. I apologize. This is the image. This is the final. So this should be your primes. I even have it right here, original. And I don't know why I confused that. The image goes on top. The original goes on the bottom. So this should not have the primes. This is the original. Okay, so let me do that down here. The original is going on the bottom. So this is the original. So that's the 4. The image, I keep wanting to use the wrong words here. The image is this distance right here. That distance. So I need to calculate that. Notice the whole distance is 4. So in this is 2, which makes this 2. So then I put that on top. So I have image divided by original. So this makes my scale factor 1/2. When also it asks up here to tell whether this is a reduction or an enlargement. And I can tell that I got smaller, plus I can tell by my number here that it's less than 1, so this would be a reduction. You're welcome to leave your answer as a fraction, or you can also change this to a decimal. So if you want to say 0.5, or if you want to say 50%, you can see how I added that 0 just because sometimes my brain automatically goes to percent. Excuse me. Excuse me. Okay. So if you want me to try another one, because I kind of was losing my train of thought on that first one, we can do number 5 together. So notice this is the original. So this is the original P, and then P prime. So I can tell you it's getting smaller. So this is going to be a reduction. And I'm going to put the image on top. Now, notice the image is right here. I can see that that's the distance. Over here, I had to calculate it. But right here, they're giving it to me. So I'm going to do image over original. So the original is 30. And again, if you want, I can reduce that. I can keep it. Or if you want to just go 18 divided by 30, we get 0.6, which would be the same thing as 60%. It doesn't bother me which one you leave it in, but in the real world, I think a lot of people deal with percents more. So I think that's just more common. So why don't you go ahead and pause it here and calculate number 6. Okay, hopefully you paused it. Number 6, if you look at the letters here, P prime. So do you see how the prime got bigger? So this is going to be an enlargement because it's getting bigger. All right, and it doesn't really matter what number you want to start with, but let's say we want to do the image on top. So the image is going to be from here all the way, which is 25. So that's the image. And then the original is from C to P without the prime. So this is your original. So 25 over 20. I mean, if you wanted to reduce this, that's what, 5/4. And if you divide that out, that's what, 1.25. Or again, if you want to go percents, that'd be 125%. So we can see if it's over 1, it's an enlargement. If it's between 0 and 1, so if it's like a decimal, then it's a reduction, or it's getting smaller. So that's how we calculate scale factor. And if you turn to the next page, you're going to be drawing some of these, but if you notice, they're on the graph. So our center is always going to be at the origin. Like I say, if it was not on a graph, if it looked like the one over here, we would need to be able to know where the center is to be able to start it. So on number 7, go ahead and graph this triangle. I was just leaving my letters off for a second because sometimes if I put my letters on there, then when I connect the lines, it kind of goes over top of it. Now, we're going to be doing a dilation with a scale factor of 2. And so if I was in class, where we were together, I would be asking you, is this going to get bigger or smaller? And you should be looking at this number telling me, well, since it's over 1, it's going to get bigger. So the easiest way to do this is just to multiply all of your coordinates by 2. You don't necessarily have to write them down, but I'm just going to write it down so you can follow along with me. So I'm just simply multiplying 2 times 2, 1 times 2, and I'm going to do the same thing for B and for C. So I'm just multiplying B, and then I'm going to take C, and I'm just going to multiply. And now I'm going to graph that. And so here is my new triangle, or my answer. So sometimes it's easier to do your work off to the side. If you can do it in your head, that's fine too, but sometimes this kind of just helps you stay nice and organized. So number 8 is very similar, so if you want to pause the video and go ahead and try this on your own, you may. Okay, I hope you paused it or tried it. Let me go ahead and graph this. Okay, kind of a strange quadrilateral, but that's okay. Now notice our scale factor is 1/3, which means this is going to get smaller. So I'm just going to take all of my points again, just because I'm getting old and I'm forgetful, and I'm going to multiply. Now, did you notice that this is 1/3 and these are all divisible by 3? That was kind of a nice numbers that they chose. If it would have not been divisible by 3, you would have had a lot of decimals. So I do like what they did here. So if I'm just multiplying by 1/3, or basically just dividing by 3, remember, 0 divided by 3 is just going to be 0. So then 6 divided by 3, 3 divided by 3, both of them, and n, just negatives. Okay, now let me graph this. Remember, it's getting smaller, but the angles will not stay the same. Look at how close those are together. Okay, so it got really close together. And it's okay if it kind of somewhat lands on the original. And so here's my new one. Again, you don't necessarily have to shade the new one. I just sometimes do that just because it helps you see where the new answer is versus the original. Okay, so we've calculated scale factor and now we've graphed it. Now they're just going to give you some kind of real life application sort of story problem situations. So we'll do a couple together and then I'll have you try a few, but this is really the last part, so we're almost done. It says you design a poster that's 8.5 by 11. Okay, so if you just want to think in your head, you don't have to draw this, but you've got this 8.5 by 11, and it doesn't really matter which dimension is which. It says the poster of the winner will be printed on, so they're going to basically have this bigger one. So this will be 34 by 44. What is the scale factor? This is the same question that we did on the other side of your page, only now it's just in words. So remember, we want to put the image over the original. So this is the image, this is the original, because this is the one that you originally did. So we're going to take the image, let's say 34, over 8.5. But my question is, what if I would have picked this one? So what if I would have picked 44 over 11? Now you do have to stay short side, long side, long side. But what if I would have picked a different combination? So let's see what happens here. Do you notice it doesn't matter? So when you're given dimensions, it really doesn't matter what one you pick. You can either go short side or you can go long side. No matter what, your scale factor is going to be 4. Now, it's very common for people in high school just to leave your answer like this, but in the real world, many people would change this to a percent. So if this is 4, I have to move my decimal place 2 to the right, so this would be 400%. Okay, so again, I don't really care, but remember, you're going to take the SAT at some point and you have to be ready for however it may be written. And so sometimes they do numbers and sometimes they do percents. So it's good just to practice them. All right, let's try another one together. Number 10, it says a biology book shows the image of an insect that is 10 times its actual size. The image of the insect is 8 centimeters long. Now, this is a slightly different setup. They're telling you the scale factor right here. This is the scale factor. So let me just get you to be thinking. We're going to do image over original, and that's going to give us our scale factor of K. So we already know the scale factor is 10 times as big. Now, it tells you the image of the insect. They're telling us the image is 8. They're asking you what is the actual length of the insect. So they want the original length. You can use whatever letter you want. Now, be very careful here. When the variable is in the bottom, you don't want to multiply by 8. Because if I were to multiply by 8, this is what would happen. I would get 64 over L is equal to 80. That really did not help me. So you always want to move the denominator. And I know that sounds funny because you're technically moving the variable, but that's what you have to do. So we're going to multiply both sides by L, and these would cancel, and we're going to get 8 is equal to 10L, and then we have to divide off the 10. Which makes sense that this number is small because an insect is small and you would be magnifying it. So you want this to be a small number. So if you work this out, you would get 0.8 is equal to the length. Now we would not change this to a percent because this is what is the length of the insect. So you just leave it. Now, if you want to put your units on, you can put your units on, but you would not change this to be a percent. You only change scale factors to be percents, okay? So in a way, these are kind of the questions that they're going to ask you. They're either going to ask you for the scale factor, or they're going to give you the scale factor and ask you for one of the missing dimensions. So if you turn to the last page in your notes here, page 12, there's 3 more problems on here. You now have seen the setup, it's just they're kind of mixed up. So why don't you quickly pause the video here and see if you can work these 3 out. Okay, hopefully you paused it. On number 11, you're asked for the scale factor. So remember, all you have to do is make sure you're going image divided by original. So it says your photo is 4. So that's the original. And the image is 1.1. And then you are going to get your scale factor. And I don't know that division off the top of my head. Sometimes I can do them in my head. So I get about 0.275. So you could either leave it like this, okay? Or if you want to change it to a percent, you only move it 2 places. So this would be about 27.5%. Or if you want to round to 28, that's okay too. All right, number 12, if you notice on number 12, it's also asking for the scale factor. And so it says, and just as a patient's eye to it a little bit, pupil's eyes dilate from this to this. So this is the image, this is the original. And again, I just have to divide that out. And I get about 1.7 repeating. So if you want to leave it like this, you can because it is a scale factor. Or if you want to move your decimal point 2 places, I guess I would probably round that to 1.78%. So either one of these is acceptable. All right, on number 13, notice they're telling us that it gets magnified 6 times. So that is my scale factor, 6 times. Now it says, determine the length of the image. So I don't know the image, but this must be the spider. So it's 1.5 like that. Now, if you notice in this problem, the variable's on the top. That's fine. It's probably the easier setup. You multiply by 1.5. So you're just multiplying both sides by 1.5, and I get 9. Now again, if you want to put the units on here, that's 9 centimeters. Okay, so basically when I look through the magnifying glass, magnifying glass, this is what it would look like through the magnifying glass. And that concludes chapter 4.